Okay, so far we described the properties of chords and arcs formed by angles from the center. Then we moved away from the center of the circle and then to the circle itself. Now let's examine the properties of angles that form outside the circle. Of course, these angles cannot be formed with chords because we are outside the circle. From outside the circle, we use secants. Now, two secants starting from a point outside the circle form an angle and cuts two arcs as they intersect the circle. Again, the question is about the measure of the angle formed by the two secants. So the angles formed by two secants that start from outside a circle is determined by the average difference of the two arcs they intersect. This means that first you find the difference between the two arcs and then divide this difference by 2. For example, if arc AB is 105 and arc CD is 41, then angle 1 is 105 minus 41, or 64. And 64 divided by 2 is 32. Angle 1 is 32 degrees. Now, angles made by a secant and a tangent or two tangents are determined the same way. For example, an angle made by a secant at the point of tangency is half the arc it intersects. Like in the case of the inscribed angle, the smaller arc diminishes to 0 as the angle starts from the circle itself at the point of tangency. Because there is no secondary arc, the angle becomes half of the only arc available. If arc AB is 110 degrees, then the angle between the secant and the tangent is half, or 55 degrees. Okay, now let's continue opening this secant until we turn it into a tangent. Now we have two tangents. With two tangents, the angle formed outside the circle by the two tangents can still be determined by the arcs that they intersect. The same way that if they were secants, the difference of the two arcs divided by 2. For example, if the major arc is 244 degrees, then the minor arc is 360 minus 244, or 116 degrees. Now we subtract the minor arc, 116 degrees, from the major arc, 244 degrees. We get 128. 128 divided by 2 is 64. So angle X is 64 degrees.